Hello and welcome to 11.4 Notes. Before we begin with the notes, let's do a couple of review items that we've covered in the past. And the first one will be that the circumference of a circle is the distance around the circle. Okay? So the circumference of a circle would be the distance around the circle. So say if that's your circle, and then this would be the whole entire distance around the circle. That's the circumference. It's sort of like saying the word perimeter, but it's a circle, so we're talking about the circumference. Okay, it's the distance around a circle, whereas perimeter is the distance around a polygon. Okay. Another piece of review is that the circumference C of a circle is C equals pi times diameter, or C equals 2 pi r, where d is the diameter of the circle and r is the radius of the circle. So write these down, get caught up. Remember, you're in total control of this presentation. You can fast forward, rewind, pause it at any time you'd like. You're in total control. Do whatever you need to do to copy these notes. But we have circumference is pi times diameter, or 2 pi r. Remember, 2 times the radius is equal to diameter, so we basically have the same basic formula to get circumference. Okay, and so these are the two pieces of review, okay, basically regarding the circumference of a circle and how to calculate the circumference of a circle, or the distance around a circle. But today's lesson is to find the arc length. Okay, today's lesson is to find the arc length. And what is an arc length? Well, an arc length is a portion or a part of the circumference of a circle. It's a portion or a part of the whole entire distance around a circle. Okay? Part of a circle. So, in other words, if you have a circle like this, an arc length would be, for example, if you have, say, point A and point B, the arc length is the linear distance or straight line distance around this circle, just this part from point A to point B, an arc length. That's an arc length. It's a portion or a part of the whole entire circumference of a circle, right? The circumference of a circle would be the whole entire distance around, but this is just a part of it, so it's called an arc length. Keep in mind we're talking about arc lengths, not the measure of an arc. The measure of an arc would be a degree. For example, say this is 105 degrees or something like that. We're not talking about that. We're talking about an arc length. An arc length can be measured with a ruler. Even though it would be difficult to measure this with a ruler, I agree, it is still basically a straight line. You can kind of think of this circle as a coin, say a dime or a quarter or something, and put a string around this arc, around this portion, this arc length, and then you can take that string, right, and you could stretch it out into a straight line. And then it would be easy to take a ruler and measure its distance. So remember, it's the arc length is a distance. Okay, it's the distance around a portion or a part of the whole entire circle. Okay. Just a quick other example. Say if this is point A again, you can have point B. This is your arc length. And again, you could take these two endpoints. Say if you put a string around that part of the circle, you could stretch that string out into a straight line, and you can measure its linear distance. It is a one-dimensional distance measured in feet, inches, yards, meters, centimeters, things like that. Distance around a part of a circle, as opposed to arc measure, which is in degrees. Okay, so remember, arc length is a length, not a degree measure. Okay. To find the arc length, use the following formula. So please write this down. You will be using this. The arc length of AB, arc AB, is equal to the degree measure of AB divided by 360 degrees times 2 pi r. So remember, the circumference of a circle is equal to 2 pi r, right? So this is basically your circumference, right? So if you think about it, if you take your circumference, which is this, and you multiply it by the fraction that the arc is taking up of the whole entire circumference, then you get the arc length, and that's what we're doing, okay? In other words, if we have, say for example, if we have this circle, and hold on, let me change that color. If we have this circle, and we know the circumference of the circle, which is the whole entire distance around, that would be that. So let's say for example the whole entire distance around this circle is 100 meters. Fine. And then say for example we knew that this was 90 degrees, and I wanted to know this arc length from here to here. Okay. Oops. Hold on. From here to here, I wanted to know that arc length. Well, if it's 90 degrees, the arc measure is 90 degrees, 90 divided by 360 is going to be a fourth. So it takes up 1/4 of the whole entire circumference. So all I would have to do is multiply this by 1/4, or divide by 4, and I get that this arc length then would be equal to 25 meters. Okay? So it's that kind of a thing. It's just taking the circumference of a circle and multiplying it by the fraction that arc length takes up. Okay, the fraction that arc length takes up. And you find the fraction by taking the degree measure and dividing the degree measure of the arc and dividing by 360 degrees, right? Because that would be the whole entire circle. Okay, let's do an example problem to see how this would work out. You have this circle here, and we want to find the arc length of AB. We want to find this distance. Okay, so in other words, if I took a string and went like this and stretched it out, I want to know how long that string would be. Okay, we're talking about arc length, not the degree measure of an arc. But again, we need to use the degree measure of that arc to find its arc length. So we'll need to know that that's a 60-degree arc measure, and the radius of this circle is 8. So again, this is the formula that you use. Arc length of AB is equal to the degree measure of AB divided by 360 degrees. In other words, the fraction that this arc takes up, or the fraction that the arc length takes up of the whole entire circle, right? And this 2 pi r is the circumference of the whole entire circle. So that's why this equation works for finding arc length. All right, filling in values, we have that this is a 60-degree measure, 60-degree arc measure. So you have 60 divided by 360, because 360 would be the whole entire circle, correct? So we have 1/6. 60 divided by 360 is 1/6. 1/6 of the whole, the arc length rather, arc AB takes up 1/6 of the whole entire circle. So if we can multiply 1/6 by the circumference, we'll have our answer. Okay? And the radius again is 8, so we'll use that. And we have 1/3 pi times 8. In other words, it was 1/6 2 pi times 8, okay? But I just multiplied 2 by 1/6, and I get my 1/3, okay? So that's where I get the 1/3 from. But again, this 16 pi would be the circumference of the whole entire circle. So if I could just go 1/6 of the whole entire circumference, I would get my answer. Okay, that's another way to look at it. So going back to the original equation here. So the way I went from here to here is I just went 2 times 1/6, which is 1/3 pi times 8, and multiplying those all out, you get 8.38 centimeters. So the distance from A to B, if I were to stretch out A to B, say a string with the length AB, it would be 8.38 centimeters long. Okay, that's the end of today's lesson. And as usual, if you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay, bye-bye.